Hey guys, so this video is going to focus on how to simplify a complex fraction. So here I have this big old lovely complex fraction over here. Remember that a complex fraction is just a fraction within a fraction. So let's get started on working on this thing. Now, my recommendation when dealing with a complex fraction is this. The first thing that you want to do is you want to rewrite this as a division problem side by side. So what we need to do is we need to remember that that fraction bar there, yes, it's a fraction bar, but it also means division. So really I have this top fraction divided by this bottom one over here. So the first thing I'm going to do is I'm going to rewrite this problem side by side as division. So that's going to look like, let's see, a 20x minus 80y over a 28. And this is being divided by x minus 4y over 7x. Now, for me, it makes this a little bit easier here because I can kind of see this division and I can see a little bit better what's going on here. And then what we also need to keep in mind is that if this is a division problem, well, we need to remember the division rule. And remember that dividing rational expressions that look like this, they follow the exact same process as dividing regular old fractions that have numbers in them. Okay, so we need to go back and maybe remember, hey, what's the rule to do a division like this? So you need to keep this in mind. Keep, change, flip. Remember that we keep the first one, we change division to multiplication, and we flip the second one. So that's going to be our next step here. Keep, change, flip. So we're going to keep the first one. That's going to stay exactly the same. We're not going to do anything or change anything there quite yet. We're going to change the division symbol to multiplication. And then we're going to flip. Another word for that is to take the reciprocal. So we'll take the reciprocal of the second one. Now we're ready to actually multiply. But when it comes to rational expressions, the multiplication step literally just means, hey, group this together all in one big fraction. Don't actually distribute or multiply anything out. Actually just group the multiplication all together. Because remember, when it comes to multiplying fractions, it's numerator times numerator, denominator times denominator. But this right here, this is my multiplication step. Just bring it all together in one big old problem. Now, the last step here, so believe it or not, we're actually at the last step here. So we changed it to a division problem. We used our division rule to rewrite it as multiplication. And technically we have multiplied here. Our last step is to simplify this thing. But what we need to keep in mind is that when it comes to simplifying rational expressions, simplify means to factor. So we need to factor this thing so that we can cancel any common factors out, and then finally we can state our final answer here. So if we need to factor this thing here, so that means I'm going to be taking a look at my numerator first, each thing in my numerator, and we're going to work on factoring that. So the first thing I have in my numerator is a 20x minus an 80y. So if I'm looking at just this thing right here, I'm looking to see, well, how can I factor that? What factoring technique would I use? Do keep in mind, regardless what factoring technique you're typically dealing with, that the first thing that we should always look for is there a greatest common factor? That always needs to be at the top of our list when we're thinking about any kind of factoring. And we definitely have a greatest common factor because here I have something in common with the 20 and the 80. Now the x and the y, they don't have anything in common. X is not the same thing as y. But 20 and 80, I definitely have a 20 in common there that I can divide out. And when I pull out a 20, remember it's like the same thing as dividing it out of each thing. 20 divided by 20 cancels, leaving us with x. Minus 80 over 20 is 4, and we drop down the y with it. Then we move over to the next thing in our numerator, and we have a 7x. So that's a monomial. And when you're dealing with monomials, the only thing you can do is stretch out that multiplication. But you can't stretch out a 7 to anything times anything. 7 is a 1 times a 7, and you never use the 1 combination. So 7 is just a 7. And that x is to the first power. We just have one of them. So that one actually just drops down. Now let's move down to our denominator, and the first thing we have in our denominator is a 28. So let's think, how can we break up a 28? So sometimes it's nice to make a little factor tree to see how the number breaks down, because looking at 28, let's see, 28 is a 7 times a 4, but that 4 is also a 2 times a 2. So really 28 is 7 times 2 times 2. And now that I'm looking at this problem here, going back to my original or my working answer over here, is I have this 20 here. And we factored out this 20 from this binomial over here. But technically, we can break up that 20 even further. And we want to do so just in case it's going to happen to cancel out with anything in the denominator. So 20, let's see. So 20 is 4 times 5, right? But 4 is also 2 times 2. So technically, this 20 is a 2 times a 2 times a 5. So let's go ahead and rewrite that 20 that way. That way we don't have to do any more simplifying in the end. So we do want to break up numbers as small as we possibly can. Using a factor tree really helps us in doing that. Otherwise, the only other thing we have in the denominator is an x minus a 4y. But I'm looking at x minus 4y, trying to see if there's any way that we can factor that. We always start by looking, is there a greatest common factor? But there's nothing in common with an x and a y. Have nothing in common with numbers. And when I'm looking at this binomial, I don't know about you, but I don't notice any factoring technique with this. This isn't difference of squares, difference of cubes, or anything like that. So that one actually cannot be simplified. So we're just going to bring that one on down. Now when we're done factoring everything, so this is the fun part, or my favorite part, because when we're done factoring, finally, we get to cancel out any common factors that we have. So anything we have in the numerator that we also have in the denominator, we get to get rid of that. So the first thing I notice is this big old x minus 4y, so I'm going to get rid of that. I also see that one of those 7's can cancel out. Also, one of those 2's can cancel out. We also have another 2 that cancels. And wow, we actually had a lot canceling out in this problem here. I don't see anything else. Do always be careful, look over everything just to be sure that you have not left anything out. But your answer for this problem is what you get when you put everything back together. So looking in my numerator, the only thing I have here is a 5 and an x. So that would be a 5x in the numerator. And actually everything in the denominator cancels out. So when everything cancels out on one side, that is a 1. So here we would have 5x over 1, but 5x over 1 is just the same thing as 5x. So technically here our final answer will be 5x. So remember, when it comes to complex fractions, for me anyways, it's easier to rewrite this as a division problem side by side so that I can use the division rule and go ahead and factor and simplify this problem.